Hello, Math 140 students. We will pick up on page 20, section 3.6. We're graphing linear inequalities. So here, we're not necessarily going into y is equal to mx plus b into graphing, but the inequality means that y, and we definitely have our mx plus b, but what's going here now instead of the equal sign is if I have less than, I can have greater than, I can less than or equal to, or greater than or equal to. So here are going to be my different options to plug in instead of that equal sign. That's what makes it an inequality. So here, for example number 1, it's asking us to determine whether this ordered pair is a solution for this inequality. So what is this telling us? Well, it gave us an ordered pair, -4, 7. So this tells us that x is equal to -4 and y is equal to positive 7. So we want to plug that into the inequality and see if it's true or false. So we have the y greater than or equal to -2x plus 3. So the y value that we're plugging in is 7, and the x value that we're plugging in is a -4. This gives me 7 greater than or equal to a positive 8 plus 3. Is 7 bigger or equal to 11? Well, let's think about this. This is 0. This is 7. On the number line, is 7 bigger than 11? And the answer here is no. So when we ask ourselves to determine, well, we just plugged in the value and we saw that it did not work, so we're going to say no. The reason we say no is because -4, 7 is not a solution for this inequality. We found it to be false. 7 is not bigger than 11. For our next example, example number 2, it's asking us to determine whether each ordered pair is a solution to the inequality. So here, we're just going to plug it into all of these different values. So let's think of this as equation number 1. So for number 1, we have x is equal to 10, and we have y is equal to a -1. So if I plug in x plus y, is that greater than a -2? And this is where we're grabbing it from, right? It all comes back to this equation, x plus y greater than -2. So the x value that I'm plugging in is a 10. That was my x value. And my y value here is a -1. So 10 plus -1 is 9. Is 9 greater than -2? It is. 9 is bigger than -2. So that's true. Now I'm going to go on to my second ordered pair here. So I have x is equal to -8 and y is equal to a positive 9. So I'm plugging it into the same equation. So x plus y is greater than -2. So the x is -8 and the y value that I'm plugging in is a positive 9. So -8 plus 9 is going to give me a positive 1, which is bigger than -2. So that one also works. Now let's try equation number 3. So I have x is equal to a -1, and I have y is equal to a -9. And I'm plugging it into my x plus my y greater than -2. So the x value that I'm plugging in is -1, and the y value is -9. I have -10 greater than -2. Is that true? Is -10 bigger than -2? It is not. So we do not include that answer. And now to give me more space, I'm going to do the exact same thing for number 4 and number 5 here. So for number 4, I have x is equal to 6 and y is equal to a negative 3. And I'm plugging it into the equation x plus y greater than negative 2. And the values that I'm plugging in for x is 6 and for y is a negative 3. 6 plus negative 3 gives me 3. Is 3 bigger than negative 2? It is. That also checks out. Now I'm going to try it with our 5th equation here. I have x is equal to 7 and y is equal to a negative 9. I have my x plus my y greater than negative 2. The x value is 7, the y value is negative 9. I have negative 9 and 7. That'll give me a negative 2. Negative 2 is not greater than negative 2. It would have to be greater than or equal to. So this does not work out. So we did not include that answer. Now here we're going to be graphing our linear inequalities on the xy graph. So just know that when you have the inequality that's strictly less than or greater than, it's going to be dotted. Versus if you have less than or equal to, greater than or equal to, then it's going to be a solid line. Then you graph the lines as you would with the linear equation, and you shade either below or above the graph as indicated. And this is where a lot of students have some difficulty of how to shade either above or below, but hopefully this video will help you. So just to kind of give you a generic kind of explanation here, remember that whenever we graph, we use that y is equal to mx plus b, where m is our slope, and that our b value here is the y-intercept. Okay. Which tells me that if I were to have the inequality with not the or equal to, so that's missing, there's no line underneath it, my line is dashed. So notice how that blue line is dashed. Versus in graph B, it has a solid line underneath it, meaning y is less than or equal to mx plus b. So here that line that's red, it's solid. And it's solid because of the inequality is or equal to that line underneath it. So let's see if we can do this. Well, I know that if I was dealing with y equals mx plus b, that this is what I would have. I would have my b value as a positive 8, which tells me that my y-intercept is 0, 8. So I know that 0, 8 is going to be my starting point. Now let's look at my slope here. M is equal to a negative 3, which is the same as negative 3 over 1, which tells me to go down 3 and to the right 1. That's how I'm going to get my slope. Okay. And remember here, my graph, let me zoom out a little bit, it all depends on the inequality. The inequality is here, which tells me that I'm going to have a solid line, okay? So I know I'm going to have a solid line. So I'm almost done. Now what I can't forget is where to shade, okay? If I have less than or equal to, which I do in this case, what we want to do is we want to shade below. So if I'm looking at that line, shading below would be here. And if you're still having maybe some difficulty thinking about like, well, how exactly did she know to shade that was below the line? Like, what would make you think that? Well, let's think about taking this point, 0, 0. So we're going to do a point check. And it might be helpful to use the point 0, 0. So this is for x and this is for y. So in my equation, I had y is less than or equal to a negative 3x plus 8. What would happen when I plug in for my x and y value? So I would have 0 less than or equal to negative 3 times 0 plus 8, which would give me that 0 is less than or equal to a positive 8. So 0 is definitely smaller than 8. That's true. So if that's true, I'm definitely going to shade the area where 0, 0 is located. That is what we're going to have. So here's another example. I have that I'm referring to y equals mx plus b to refer what the values are. So here 4 is equal to my b. So my y-intercept is 0, 4. That's going to be my starting point. I also have my slope. That's the number in front of the x. So that's negative 3 over 5. So that tells me down 3 to the right 5. Or I can go up 3 to the left 5. So according to my slope, go down 3 and over 5. Or from my original point, go up 3 and to the left 5. And that would be my line. Now I have to be careful. Look at this inequality. What does it tell me? It's strictly greater than. So that tells me that the line is going to be dashed. So I'm going to go ahead and draw a dashed line here. Now that I have my graph, I can't forget that I also now have to shade. So here I have y is greater than my negative 3/5 x plus 4. So I want to be careful about what this is saying. This is greater than. So if it's greater than, then I'm going to be shading above. So since I'm going to be shading above, that's going to be here. That's above the line. And if you're like, wait a minute, that doesn't make any sense, well, you can do your test point again. So a good point sometimes is 0, 0 when x is 0 and when y is 0. So if I have y greater than a negative 3/5 x plus 4, if you plug in 0, you would get 0 is greater than 4. That would be false. This is not true. So since 0, 0 is here, and it's false, then what you do is you shade opposite of line. So that would be where it's green and shaded above. Now let's look at letter C here. So for letter C, I have this equation, but it's not in that y equals mx plus b. So I have a negative 2x plus 2y greater than negative 6. So to get the y isolated, I'm going to add 2x to both sides. That'll give me 2y greater than a positive 2x minus 6. From here, I can divide everything by 2 and get y is greater than 1x minus 3. So I know that my y-intercept, where I'm going to start at, is 0, negative 3. So that is my y-intercept. And now my slope, which is 1, that's the number in front, I'm going to have that as 1 over 1. So it's up 1 to the right 1, or down 1 to the left 1. And I know, because of the inequality, I have this greater than. So I really have y is greater than 1x minus 3, which tells me that it's going to be a dotted or dashed line. So it's broken up. And it tells me, since it's greater than, that I'm going to be shading above. So everything, not touching the line, but really close to the line. So that's the part that I'm going to be shading. Again, if you wanted to do the test point of 0, 0, you would plug that in. You can see that 0 is greater than negative 3. So that would be correct. So if I'm looking at that point 0, 0, which makes this inequality true, if I do the test point method, then I know I'm going to be shading on that side that contains 0, 0. If it's false, then I would shade the opposite side that does not contain 0, 0. So let's look at one more example. So here I have my y-intercept at 0, 1. I can see my slope as a negative 1. So that's going to be negative 1 over 1. Or better yet, down 1, right 1. Or up 1, left 1. So if I go down and to the right, this is what my graph is starting to look like. Or I can go up 1 and to the left 1. So that's what it looks like. Again, I have y is less than or equal to negative x plus 1. The fact that it's solid here, this is my less than or equal to. The fact that it's the or equal to, it has that line underneath. So it tells me that my line here is going to be solid. And since it's less than, then that means below. So this is where I'm supposed to be shading for this graph. Now, a little bit different, changing gears. It says, write the inequality shown by the shaded region in the graph for the boundary line. So I definitely have my y-intercept at negative 4, and I definitely have my slope here. So I'll go ahead and rewrite this. So y-intercept is 0, negative 4. That's given to me. That's my y-intercept. I have my slope, which is a negative 5 over 3. That's this, but it wants to know whether or not it should be a solid or dashed line, which is going to determine whether it looks like this or this. Okay. Well, let's think about this. Let's look at this blue line. So I'll even write it. Look at blue line. Is it solid or dashed? Well, you can see that the blue line is really a solid. So I know that I'm going to have this or this, the greater than or equal to, and the less than or equal to are the only two options that I have. So that means I can't have that less than or that greater than. It's less than or equal to, and the other option is greater than or equal to. Now let's think about where it's shading. So here, shading. Is it above or below the line? Well, you would say that it's shaded above the line. So I can say if I have y, and I have my negative 5x over 3 minus 4. What they want me to figure out is what goes here. It's not going to be an equal sign. I already know it's going to be greater than or equal to, or less than or equal to. Since I'm shading above, then that is going to be my answer, greater than or equal to. So my final answer is going to be y greater than or equal to my negative 5x over 3 minus 4. So they really wanted to know what the inequality, if it's a line underneath it, and which way it's facing, whether it's less or greater. Okay, and that is the end of this section. If you guys have any questions, please feel free to email me. Thank you.